In this lecture of Laplace transform, we shall consider multiplication of f of t by t. That means what happens if the given function f of t is multiplied with t or with t square or with t cube, and then we would want to find the Laplace transform of t f of t. Now we know that the Laplace transform of f of t is integral 0 to infinity e power minus st f of t dt. Now if you need to have t f of t, then what we have to do is we need to differentiate f of s with respect to s. Now Laplace transform of f of t is nothing but f of s. Differentiate this expression with respect to s. So differentiating the expression with respect to s. So you have d by ds of f of s equals 0 to infinity e power minus st. So I'm differentiating this with respect to s, so I get minus t into f of t dt. Right? So I take minus sign outside, so it is minus 0 to infinity e power minus st. So you have t f of t dt. So I take minus sign to the other side, or I multiply the whole equation with minus sign. So we get minus 1 into d by ds of f of s equals 0 to infinity e power minus st t f of t dt. Right? So this is nothing but the Laplace transform of t f of t. So here we are multiplying f of t with t once. Suppose we multiply f of t with t twice. That means if I have t square f of t, then what happens? Then it would be differentiating f of s with respect to s twice, and you need to multiply this term with minus 1 two times, so it would be minus 1 whole square. So if it is t cube, then it is differentiating ds with respect to s thrice and then minus 1 whole cube. So instead of t cube, I could have t power n. So if f of t is multiplied with t power n, then differentiate f of s with respect to s n times and multiply it with minus 1 n times. Right? So therefore this is nothing but Laplace transform of t power n f of t. Right? So therefore Laplace transform of t power n f of t is equal to minus 1 whole power n d by ds of f of s differentiated n times. Right? So f of s is differentiated with respect to s n times if f of t is multiplied with t n times. So using this relation, we shall solve a few problems. Example 1. Find the Laplace transform of t e power minus t. So remember, in all these cases, what we need to do is find the Laplace transform of f of t, which would be f of s, and then differentiate f of s with respect to s, and then multiply it with minus 1. So if I have to find the Laplace transform of t e power minus t, you consider f of t equal to minus t, that is e power minus t. So therefore f of s is equal to 1 by s plus 1. Right? Using this relation, Laplace transform of e power minus at is equal to 1 by s plus a. Here a is equal to 1. Now differentiate this with respect to s once, because it is multiplied with t once. So d by ds of f of s equals denominator square, denominator into differential of numerator, which is 1, which is 0, minus 1 into differential of the denominator, which is 1 again. So this is going to be minus 1 divided by s plus 1 the whole square. Right? So now we know that Laplace transform of t f of t is nothing but minus 1 d by ds of f of s. So I have to multiply this with minus sign. So minus into minus becomes plus, so it would be 1 divided by s plus 1 the whole square. Example 2, we need to find the Laplace transform of t sine at. So here consider f of t equals sine at. And what is f of s? We have to find the Laplace transform of sine at. So Laplace transform of sine at is a divided by s square plus a square. Now this entire term is multiplied with t once. So I have to differentiate this with respect to s and then multiply it with minus 1. So d by ds of f of s equals s square plus a square the whole square, denominator, into differential of numerator with respect to s is 0, minus a into differential of denominator is 2s. So this would be minus 2as divided by s square plus a square the whole square. So Laplace transform of t sine at equals minus 1 into this. So minus 1 into this entire term. So it becomes 2as divided by s square plus a square the whole square. Right, so this term I am multiplying it with minus 1, so the whole term becomes positive. So the answer is 2as divided by s square plus a square the whole square. Example 3, find the Laplace transform of t cos square t. Right, so first find the Laplace transform of cos square t. So cos square t can be written as 1 plus cos 2t by 2. So I have 1 by 2 into, find the Laplace transform of 1 plus the Laplace transform of cos 2t. So this is 1 by 2 into 1 by s plus s divided by s square plus 2 square. Right? So we know that Laplace transform of cos 2t or cos at is s divided by s square plus a square. So now Laplace transform of t cos square t is nothing but minus 1 d by ds of f of s. What is f of s? This is f of s. So you have minus 1 by 2. Differential of 1 by s is minus 1 by s square plus differential of this term. So you have s square plus 4 the whole square, denominator, into differential of numerator is 1 minus s into differential of denominator is 2s. So we have minus 1 by 2 minus 1 by s square plus denominator is s square plus 4 the whole square. You have s square plus 4 minus 2s square. So this is minus 1 by 2 minus 1 by s square. So you have minus s square plus 4 minus s square plus 4 divided by s square plus 4 the whole square. So now multiply both the expressions with minus 1 by 2. So we get 1 by 2 s square plus, so this entire expression I am multiplying it with minus sign. So you get 1 by 2 into s square minus 4 divided by s square plus 4 the whole square. Right, so this is the Laplace transform of t cos square t. Right, so it is 1 by 2 s square plus s square minus 4 divided by 2 into s square plus 4 the whole square. So example 4, find the Laplace transform of t sine 2t cos hyperbolic t. So first let us consider sine 2t cos hyperbolic t. So let this be f of t, right? So I have sine 2t and cos hyperbolic t, I'll write it as e power t plus e power minus t by 2. So this would give me 1 by 2 into e power t sine 2t plus e power minus t sine 2t. So we need to find the Laplace transform of this entire term. So this would be equal to 1 by 2 into Laplace transform of e power t sine 2t plus Laplace transform of e power minus t sine 2t. So when a given function is multiplied with e power at, that is, if f of t is multiplied with e power at, then what do we do? Find f of s and then substitute s equal to s minus a if a is positive. If a is negative here, it would be s plus a. So basically what we have to do is 1 by 2. Laplace transform of sine 2t is 2 divided by 2 square plus 4. And here a is 1. So wherever s is there, replace it by s minus 1. Plus 2 divided by s square plus 4. So this is e power minus t. So a is minus 1. So wherever s is there, replace it by s plus 1. So this would be equal to 1 by 2. 2 divided by s minus 1 the whole square plus 4 plus 2 divided by s plus 1 the whole square plus 4. So this is equal to, so 2 gets cancelled. So this is 1 divided by s square minus 2s plus 1 plus 4 is plus 5. Plus 1 divided by s square plus 2s plus 5. Right? So you get 1 plus 4, which is 5. So this is f of s. So now this entire function f of t is multiplied with t. So I need to perform minus 1 d by ds of f of s. So we have minus 1 into differential of f of s. So you have s square minus 2s plus 5 the whole square. Right? So denominator into differential of numerator. Numerator is 1. So differential of 1 is 0. Minus 1 into differential of denominator. So you get 2s minus 2 plus denominator square. That's the second one. S square plus 2s plus 5 the whole square. Denominator into differential of numerator is 0. Minus 1 into 2s plus 2. So what do we get? We get a minus sign here. So this is 0. This is 0. So you get minus 2s minus 2 minus of 2s plus 2. But these two terms are being multiplied with a negative sign. So these two become positive. So you get 2s minus 2 divided by s square minus 2s plus 5 the whole square plus 2s plus 2 s square plus 2s plus 5 the whole square. Right? So this is the answer. If required, you can take 2 outside, which is common. So you would get 2 into s minus 1. Here you would get 2 into s plus 1. So this is the Laplace transform of t f of t. Find the Laplace transform of t root of 1 plus sine t. So let this be f of t. Now we know that sine 2 theta equals to sine theta cos theta. So instead of 2 theta I have t. So I would have here t by 2, right? So this entire function f of t can be written as root of 1. 1 can be written as sine square t by 2 plus cos square t by 2 plus sine t can be written as, so this is sine t equals to sine t by 2 cos t by 2. 2 sine t by 2 cos t by 2. So why am I doing this? So that I can remove the root. So this is of the form a square plus b square plus 2ab. So I can write it as sine t by 2 plus cos t by 2 the whole square, the whole root, which is sine t by 2 plus cos t by 2. So this is f of t. Now what is f of s? The Laplace transform of these two. So sine at is given here, cos at is given here. So a is 1 by 2. So you have 1 by 2 s square plus 1 by 2 whole square plus s divided by s square plus 1 by 2 the whole square. So let us simplify. You get 1 by 2. So this is s square plus 1 by 4 plus s divided by s square plus 1 by 4. So taking the LCM, you get 4s square plus 1, right, 1 by 2, so 4 goes on top, plus 4s divided by 4s square plus 1. So 2 2s are 4, so this is 2 plus 4s divided by 4s square plus 1, because the denominator is common. So the numerator is 2 plus 4s divided by 4s square plus 1. So this is f of s, right? So now what do we have to do? This is multiplied with t. So I need to perform minus 1 d by ds of f of s, which is minus 1. Differentiate this. So you have denominator square, 4s square plus 1 the whole square, denominator into differential of numerator, which is 4, minus numerator into differential of denominator, which is 4s square plus 1 is the denominator. So if I differentiate this, I get 2 into 4s, which is 8s. So multiply, so you get minus 1, 4s square into 4 is 16s square plus 4, minus 2 into 8 is 16s, minus 4 into 8 is 32 s square divided by 4s square plus 1 the whole square. So 16s square minus 32s square is minus 16s square. So you have minus 1 into minus 16s square minus 16s plus 4 divided by 4s square plus 1 the whole square. Right? So multiply the whole numerator with minus sign, and you can take 4 common outside. So you get 4s square plus 4s minus 1 divided by 4s square plus 1 the whole square. So therefore the Laplace transform of t root of 1 plus sine t equals 4 into 4s square plus 4s minus 1 divided by 4s square plus 1 the whole square. Right? So we have solved a number of problems where you have the given function f of t multiplied with t. So do not forget to like, share and subscribe, and press the bell icon to get notifications of all the further uploads, and thanks for watching.